Our goal is to prove that the transpose of the summation of matrices is equal to the summation of the transpose. We're going to use the method of induction. In the method of induction, we start by inductive step. In the inductive step, we prove this relation when n is equal to 1. What do you have on the left-hand side? On the left-hand side, we have parentheses A1 transpose. What do you have on the right-hand side? On the right-hand side, you have A1 transpose. I'm leaving the parentheses here. But parentheses doesn't change the fact that you're finding the transpose of the matrix, and these two must be equal to each other. So we don't have any issue with the inductive step. We're moving to hypothesis. In the inductive hypothesis, we assume that this relation is true for any k less than equals to n, and we prove it for k plus 1. So one by one, we try to see how we can analyze this relation. What do we mean by that it is true for k less than equals to n? When we say that, the relation is true for k less than equals to n, it means that if you add A1 to A2 to A sub k and finds the transpose of this summation, it is equal to the summation of their transpose. Dot, 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 A sub k transpose. Now we prove this relation. Our goal is to prove this relation for the case that you have k plus 1 matrices. Okay, let us begin. On the left-hand side, what do we have? We have parentheses. Just going to copy down everything. A1 plus A2 plus dot, 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 plus A sub k plus A sub k plus 1. And you're finding the transpose of this summation. What do you have on the right-hand side? On the right-hand side, we have the summation of the transpose. Your goal is to show that these two are equal to each other. A sub k transpose plus A sub k plus 1 transpose. What I'm going to do, I'm going to take these and call it matrix B. If I do that, what happens on the left-hand side? You get the matrix B plus A sub k plus 1 transpose. But remember the behavior of the transpose. If you add two matrices together, And find the transpose is basically writing the very first matrix transpose and add that to the transpose of the second matrix. But what is B transpose, right? You're basically substituting this guy here. You're saying that this guy is equal to A1 plus A2 plus dot 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 plus A sub K transpose plus, now you just copy down this guy here, A sub K plus 1 transpose, but from inductive hypothesis, we already know that. Let me highlight this for you. We already know that the transpose of the summation of A1, A2 through AK can be written as the summation of the transpose. So just substitute this down here. So in turns, this guy is equal to A1 transpose, A2 transpose, plus dot dot dot, AK transpose. And then you have another matrix to add, which is A sub K plus 1 transpose. Well, now compare left-hand side and right-hand side. Your left-hand side is equal to right-hand side. Comparing left-hand side and right-hand side, we see they are equal. So your conclusion is, by the method of induction, we showed that if I take some matrices A1, A2, dot, 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 AN, and find their transpose, it's nothing but the summation of their transpose. You can write it this way as well. The summation of A sub I starts from 1 to N transpose, is equal to the summation of AI transpose, I starts from 1, goes to N. So let us recap what we did. We wanted to prove that A1 plus A2 plus A3 transpose is equal to the summation of their transpose. We used the method of induction. In the inductive step, we proved the relation for the smallest value in the domain. So this is the smallest value in the domain. Which in this case is 1. Sometimes it's 2, sometimes it's 3. That depends. On the left-hand side, looking at this relation, your left-hand side starts at A1. So your left-hand side is open close parenthesis A1 transpose. On the right-hand side, you have the summation of the transpose. So on the right-hand side, you have the transpose of A1. But having parentheses doesn't change the fact that you are finding the transpose of the matrix. Now let us move on to inductive hypothesis. In the inductive hypothesis, we assume this relation is true for any k less than equals to n. And your goal is to show that it is true for k plus 1. One step ahead. When we say that the relation is true for k less than equals to n, it means that the summation of the matrices and taking the transpose is equal to the summation of their transpose. Now, your goal is to show that this relation is true for k plus 1. On the left-hand side, you have a1 plus a2 plus ak, and you're going to add ak plus 1 because the last index must be k plus 1. On the right-hand side, you're going to list everything and add ak plus 1 transpose. We begin by analyzing the left-hand side. I'm going to group these matrices together and call it matrix B. So basically, you can simplify this into open close parentheses B plus A sub k plus 1 transpose. It makes it easier for us to see the pattern. Remember, based on the relation of the transpose that you proved in this class, A plus B transpose is equal to the transpose of A plus the transpose of B. So since you already know this, you can apply it for B plus A sub k plus 1 transpose. Well, in turns is equal to the transpose of B plus the transpose of AK plus 1. But what is B? B is A1 plus A2 plus AK. And based on inductive hypothesis, you can replace this by the transpose of A1 plus the transpose of A2 plus the transpose of AK. And when you add the last matrix, it is the transpose of AK plus 1. Now compare left-hand side and right-hand side. They are basically the same. They are equal to each other. So now that you have equality, it means that left-hand side and right-hand side are equal to each other. What's the meaning of that? It means that by the method of induction, we prove that the transpose of the summation of matrices can be written as the summation of their transpose.